So let's get started with Chapter 4. In Session 1, I want to introduce you to data center virtualization concepts and products, as well as the products are most commonly used in today's data center and cloud computing environments. Let's get started by taking a look at hyperconvergence. I like to define hyperconvergence as an infrastructure model in which hardware resources are represented by software structures, making them independent of the specific hardware device. For example, in this diagram, compute resources, such as memory and CPU, can be hyperconverged into virtual machines. Network resources can be hyperconverged using things like software-defined networking into virtual switches. And then storage devices can be hyperconverged into storage pools. The software-defined data center, then, is a data center in which hyperconverged resource pools are assigned and accessed through the use of virtual machines, and also container-based applications that we'll be looking at later. Data center virtualization products are typically built on Type 1, or bare metal hypervisors. As I discussed in Chapter 1, these Type 1 or bare metal hypervisors provide for maximum performance along with special data center features. Some of these features include things like hardware virtualization support for AMD-V and Intel VT technologies. Data execution protection, also known as NXXD, prevents a rogue virtual machine from accessing the memory space of other VMs running on that hypervisor. Secondary level address translation, or SLAT, and ballooning can help to improve paging speed as well as memory utilization. Enlightened I/O is a Hyper-V feature which allows the guest operating system running in a virtual machine to send requests directly to a hypervisor and therefore gain some additional features. Non-uniform memory management, NUMA, and transparent page sharing are both VMware vSphere features, and we'll be taking a little bit more of a look at them here in another slide. High scalability is another advanced feature of data center virtualization products, providing support for many more CPUs and memory. And then clustering features allow hosts to be put into clusters and therefore provide for things like load balancing and fault tolerance. If one host is bogging down, virtual machines can be moved from that host to a different host automatically. And disaster recovery, of course, provides a way for us to keep our data accessible despite equipment and even failure of an entire site. I've grouped data center virtualization products into three major categories: those from VMware, those from Microsoft, and open source. VMware is currently the leader with its vSphere environment. vSphere includes a vSphere hypervisor that's available in both free and licensed versions, as well as vCenter Server, which is necessary in order to build software-defined data centers that consist of multiple licensed vSphere hosts, clusters, and other advanced features for networking and storage. vCenter Server is a licensed product and will be working with both vSphere Hypervisor and vCenter Server in Chapters 7 and 8. Hyper-V is Microsoft's flagship product, and it comes with Windows Server 2008 and later, as well as a client version that's available with Windows 8 and Windows 10. In order to set up software-defined data centers and other advanced features, you also need Virtual Machine Manager, which is part of the licensed System Center product. You'll get a chance to work with both Hyper-V and Virtual Machine Manager in Chapters 5 and 6. Major open source virtualization products include Xen or Xen Server and KVM. Now, we won't be working with these open source products directly in our textbook, but you should be aware of them as they're very important in the industry. First of all, Xen or Xen Server is now part of the Linux Foundation. It was really the original open source Linux hypervisor, but while older was not a part of Linux but its own platform. The newer Zen server is now part of Linux Foundation and is used by major cloud platforms including AWS, IBM, and Rackspace. Generally speaking, Zen is tuned to host Linux guest environments. KVM is the other leading open source product. It's a little more recent hypervisor, and it comes from a commercial project that Red Hat brought into Linux. It's now part of the Linux Foundation. KVM is generally tuned to host Windows guests better, and is therefore a bigger contender in some of the virtualization or software-defined data center space. Starting with vSphere 5 in 2011, VMware redesigned the hypervisor to provide improved performance and reliability, doing things like removing the service console that was part of the older ESX hypervisor. The console is now part of the client, and they changed the hypervisor name slightly from ESX to ESXi, where I stands for integrated. The vSphere product can be divided into three major components. The vSphere ESXi hypervisor, which is available in both free, standalone, and licensed versions. The vSphere client, which is available in a GUI that can be installed on Windows or web-based version. And the vCenter server, which has the software-defined data center features we've been talking about, but it works only with licensed versions of the ESXi hypervisor. Some of the features that we see in vSphere. The core of the vSphere ESX hypervisor is called the VM kernel. It controls all virtual machine access to the host computer's hardware. This slide shows some of the features that come with the free and licensed version of this hypervisor. Notice they all include support for secondary level address translation, ballooning, transparent page sharing, memory compression. Both have comparable memory and processor capabilities. Another feature is the non-uniform memory management access, which was mentioned earlier. That's a memory management protocol that's used in multi-processing environments. With NUMA, a CPU can access its own local memory directly, and that's faster than accessing the shared memory, so we improve the overall performance of the virtual machine. And transparent page sharing, or TPS, allows identical pages of memory to be shared between VM. And this reduces the amount of memory needed in your host computer, especially important when you're running multiple copies of a guest OS, such as in a virtual desktop environment. Page 149, talk a little bit about the memory compression feature, which reduces the amount of swapping necessary by compressing unused memory pages and then decompressing them when they're needed, instead of swapping them in and out of the secondary storage. We also have another feature called hot add support, and this allows the vSphere host to dynamically change a guest VM's number of CPUs or memory size while it's running. And this is very important to load balancing, as guests may need more or less memory and CPUs. Here's a comparison of those features again between the free and licensed versions. Notice the virtual machine itself is limited to 8 vCPUs in each VM. We also see some differences as we go into clustering, because this is not available. Load balancing, high availability, hot add, all of these advanced features are only available if you have the licensed vSphere product. Activity 4-1 on page 150 is intended to have you download the free vSphere hypervisor and client. If you'll be doing the activities in the book, you'll need to have this software in order to install and work with vSphere hypervisor. However, if you're using MindTap and Live Virtual Machine Labs, you can skip this activity if you like, since you'll have the software already in the lab image. Next, we'll take a quick look at Microsoft Hyper-V, some of its components and features. Hyper-V first came out as a Type 1 hypervisor with Windows Server 2008. Since then, there have been a number of Hyper-V releases, including client versions for Windows 8 and Windows 10. Here's a quick look at some of the different resource platforms and how they compare in terms of processors and clustering information. Notice that the 2016 Hyper-V is definitely boosted up from the version that came out with 2008. As we mentioned, Microsoft also provides a system center that's used to manage software-defined data centers with multiple hosts and clusters. It's a licensed product that includes Virtual Machine Manager and also provides capability for high availability, such as fault tolerance and disaster recovery, as well as clustering. Hyper-V is still playing catch-up, if you will, to vSphere and vCenter Server, but they have a large base of users and rapidly gaining ground on VMware's vCenter environment. In Activity 4-2, you'll need to actually be working on a Windows Server platform. So this activity will not work if you're using MindTap and the Live Virtual Machine Labs. You actually have to be able to boot your local computer into Windows Server 2008 or 2016 in order to perform these processing steps. As a quick summary, prior to virtualization, servers were using only about 15% of their capacity. So as virtualization technology and products have improved, data centers have begun to take advantage, and today almost all data centers use virtualization. Reduces hardware and facility costs, allows multiple virtual machines per host, and many other features. In addition to hyperconvergence of resources, data center virtualization also offers a number of services such as clustering, load balancing, high availability, hyperconverged networks, and storage systems, as well as distributed resource schedulers that allow you to perform load balancing on an automatic basis. VMware has a product called vMotion that allows you to automate moving virtual machines between hosts. VMware vSphere is currently the data center product that's probably has the most advanced features, including support for 8 to 16 virtual CPUs and 16 terabytes of memory, security through NXD and XD, secondary level address translation, transparent page sharing, and memory management NUMA to increase memory performance. VMware vCenter Server requires a licensed version of the vSphere ESXi hypervisor in order to provide these capabilities. Microsoft Hyper-V is rapidly gaining market share, has the advantage of being included with Windows Server and Workstation products. Other open source products we talked about includes Xen Server and KVM. Xen Server probably being the most popular in the cloud environment today. So that brings us to the end of session 1 on data center virtualization concepts. In session 2, we'll be taking a look at data center storage systems as covered on page 153 through 159 of your text.